Welcome to Biologically Complete Composting. I'm Sarah Skamness with Cress of Soil Services, your host and instructor for today, and we will be reviewing the bioreactor method. So let's start out with just talking about what is compost. So compost is pretty simple. It's just a decomposition of organic material. So what's all this hubbub about aerobic versus anaerobic decomposition? It's very different in the outcome and what you get. So it's the biology that will determine the quality of the compost and what's in there, what nutrients were retained in that compost if it was composted aerobically versus anaerobically. So let's go through that. Aerobic decomposition. So this happens in the presence of oxygen, and that oxygen, a certain level of oxygen, and that oxygen selects for a very specific set of obligate aerobic organisms, these soil food web members that do the work in the soil that you're after, that your plants require basically for their symbiotic functions. So these are the organisms that in that presence of oxygen and while they're present, they break down that organic material and they retain the nutrients that are in that material into their bodies. And then through that soil food web loop, the poop loop, as they're eating each other, those nutrients become then available in that compost. So you have a lot of bioavailable nutrients that are retained in that compost. They also produce humic and fulvic acids, a whole suite actually of organic acids that are beneficial enzymes, and all kinds of other beneficial compounds that support constructive life processes. And disease is selected against. It cannot proliferate in aerobic conditions. So in anaerobic decomposition, this happens in a lack of oxygen, below a threshold of oxygen in the compost. And because that environment is so low in oxygen, it selects for organisms that can not only tolerate but thrive in that lack of oxygen condition. So these are your anaerobic decomposing pathogens, basically. They're not the ones that are going to be building soil. They're not the ones that are going to be retaining any nutrients in your pile. So with that lack of oxygen, you lose those nutrients. They're not being held in any bodies of organisms. They're actually off-gassing as ammonia. You can smell ammonia. You can smell rotten eggs sometimes. Anything putrefying. Those are all of your nutrients that are just leaving as a gas. So this is what happens in an anaerobic process. They also will make as an end product, as an end metabolite, volatile and toxic compounds like alcohol. These things are not going to be beneficial for your plants. And this is why, we harp on the difference between aerobic decomposition and anaerobic decomposition. You get a very different end product when you select for oxygen versus not selecting for oxygen. These harsh compounds that these anaerobic organisms produce, they deconstruct living processes. And disease is then selected for. This is the condition that pathogens can survive in and thrive in. So this is a big difference, and you need to understand when you're going through this process how important it is to keep aerobic, why we talk about certain like high nitrogen components in the pile as making sure that they don't come from, or at least not too much from, a facultative anaerobic process like beer mash, because you don't want to then start selecting for these anaerobic microbes that come on this material and start this process going. So we'll walk through all those details, but I just wanted to take a moment and make sure that we understand that it's very important to keep it aerobic because we're after a very specific end goal. And that end goal is biologically complete. So what does biologically complete mean? So it basically, we're just saying this compost, we've taken a certain specific process of decomposing that maintains aerobic conditions and selects for aerobic microbes that do the decomposing and that basically also meet biological biomass minimums. So all of the aerobic beneficial members of the soil food web are there. Those are the ones that build your soil and decompose and give you those nutrients. And they're there in numbers. So a biomass minimum, a certain volume, needs to have been met in order to be considered biologically complete. That means this compost, at the end of making it, if you meet these minimums and all those members are there, then this compost can be used in so many ways as what we call an inoculant. So making compost extracts and even a compost tea if you'd like. You've got those those very specific soil food web members that meet this definition of biologically complete. And those are the ones that give you that concentration of the bioavailable nutrients. So that's why we delineate between aerobic decomposition and anaerobic decomposition, and make a point to say we are specifically, not only are we doing decomposition aerobically, but we're specifically trying to breed these sets of organisms at a certain volume. For more information about our thermal composting modules and mentorship program, visit our website at cressofsoil.org. Look for our modules under the Learn tab or click the link in the description below.